Okay, let's talk about data types, what they are, how they can help us, why we kind of use them, and everything in between. So I have a sample application here. It doesn't really do much. We declare and initialize two string variables here, and we output them to our black window. So when I run the application here, it just says SpongeBob SquarePants. So I thought of an example on how to explain data types a lot easier. And I came up with an example. Have you ever played Top Trumps or Pokemon cards or Yu-Gi-Oh or something like that, where you have the name of the character, maybe some attributes like age, weight, height, rarity, or things like that. And I think that would represent data types quite well and help me explain them so you understand them a lot easier. So imagine a card, it has a name, and it might have an age, for example. So this is the age of the character. Now, SpongeBob is one of those characters that transcends all age, but I'm going to put 21. So this is a string type variable, and this is a data type. Another data type we can use is what's called an integer. Now, what an integer is, it's a number. We can actually hover over it, and Visual Studio actually gives us more information about this. So it represents a 32-bit signed integer. 32-bit just means the size, how much information you can put in here. I think it's anywhere from -2 billion to +2 billion. So I think using age fits this quite well. It's only going to be 2-3 digits. When we use integer type variables, we don't need these double quotes like on strings. We just need a number right here. So another one might be maybe the weight, and that will be in pounds. Maybe this sponge is around 120 pounds, something like that. Another one, height. Now height, we're going to put it in feet and inches, and I'm going to put it in feet and inches so I can show you a new data type, and this is called a double. Now what a double is, it represents decimal numbers. So let's put height in here. Let's say our sponge is 3 feet 4 inches, for example, something like that. So that's the height of our sponge. And if we hover over double here, it represents a double precision floating point. Very complicated, isn't it? And this is why people learn from tutorials. So a double represents a decimal. So this is anything with a decimal point. So now decimals, let's talk about decimals real quick. In C# we can represent a decimal number in one of 3 ways. Another one is called a float. Let's put numbers after this. When you use a variable, they all need to have unique names. So let's do decimal, and that's another way how we can represent decimal numbers. So these are the 3 ways we can represent decimals in C#. And the main difference is the precision. Now float is, I believe, 32-bit, so it's only 7 digits. You can give it more than 7 digits, but it will cut it off, truncate it at 7. So you lose everything after 7 digits, which is all this accuracy here. Now, a double, 64-bit, so slightly more, I believe 15 digits, 15 to 16 digits. So it's more accurate, so we can put up to 15 in here. And by default, a double is used when you use decimal numbers in C#. And when I say default, I'll explain that in a second. And the last one is decimal. And this one is huge. I think it's 128-bit, lots and lots of digits. I think 28 digits, so quite long. And we use decimals when we talk about money, things to do with money. Maybe if you write an application to handle taxes, and we want, as a government agency, for example, we want to make sure everyone pays their taxes to a really far out there decimal point. So when you deal with money, it needs to be really, really accurate. And that's where we would use a decimal. you can see here when I initialized this float data type variable, height1, I put a little f at the end here. This tells C#, hey, I want to initialize a float value. And this is because it uses double as default. You can see when I initialize a double, I don't need to put a letter at the end. So anytime I put a decimal value here, C# will assume it's a double. So if I want to initialize a float here, I have to say, oh, by the way, this is a float data type. Because if I don't do that, you can see there's a red line. I hover over it and it says literal of type double cannot be implicitly complicated, isn't it? So it basically says use an F suffix to create a literal of this type. So it's basically saying, hey, you have a float data type, put an F at the end, and then we're happy. Same with decimal. I don't know whether you don't use a D or something more descriptive. It's probably used by something else. So this one wants an M. And similarly, if we don't put an M, it's telling you to put an M. So this is why IDEs, it's called IDE, like Visual Studio, are really good. It's actually telling you what you're missing and what you need to do. If you use something like Notepad, it's not going to tell you this. So it helps you program a lot faster. So these are the three ways we can represent decimal numbers. And we're just going to use a double for the height. And the height of our sponge is 3 feet 4 inches, something like that. I think that would be good. Now the next one I want to introduce is a Boolean represented by bool. And this could be, what could the Boolean be? Oh, whether our trading card is first edition. So I'm going to put is first edition. I'm going to say true. SpongeBob is a very rare trading card and it's first edition, so it's going to be true. Now Boolean data types can have the value true or they can have the value false. So only one of those two values. So true if it's yes or false, no. So that's how we use Booleans in C#. It's true or false, so only two values. If you want a variable that might have 3 or 4 values, then don't use a Boolean. Boolean are for only 2 values. And the last one I'm going to talk about, now there's loads of data types in C#. We can do dates, times, various complicated things like lists and things like that. But to be honest, with strings, integers, decimal values like the double, Booleans and characters here, we can pretty much write anything, lots and lots of software with only these data types. So perhaps we'll cover more in the future. So the last one I'm going to talk about is characters represented by char right here. And for this I'm going to call it grade, like the grade of our card. Is it excellent? So that might be A. Or is it bad? That could be an F. Then an average card might be C, like when you take an exam. So our grade might be something like that. And this is a very good card. It's first edition, mint quality. We give it a grade of A. And when you initialize character variables, we use single quotes, not double quotes here. And Visual Studio does a good job here. If you forget the quotes, it will probably tell you you need them or give you a cryptic error like this one. So yeah, character, single quotes. So now we've declared and initialized all our various variables with all their different types, and I just want to output them to the screen. So you can see they have the green line under each one right now. So when I use age down here, watch that green line disappear under age, and that's because we're now using it. So now I'm going to put one for every different variable here, and through the power of editing, we can see here now we're outputting all of these to the screen. So if we run this application now, we can see all our various values for all our different variables. So we see the first name, the last name, the age, the weight, the height, true because it's first edition, and also our grade because it's a very good trading card.